So the opposing pairs will operate kind of like a voltmeter, making those electrical measurements of the moon.
Right. And there's 4 of them, it looks like. They look like they're about the size of a pickleball.
That would be correct, yes.
Or softball.
Yeah, and they'll be deployed hopefully about 60 feet out from the lander.
That's amazing. So, Ray, if these things got to kick out from the lander, how did you coordinate where they were going to go?
Yeah, so, we talk about these 10 payloads. There's 28 different components, and this is a great example of that. So these probes are mounted on the edge, and as he mentioned, they'll shoot off the side of the lander, and then there's also a mast on the top deck that will shoot up. So there's going to be communication from the probes on the lunar surface up to that mast. So it's very interesting. A
complex arrangement, but we're going to get some exciting data from it.
Absolutely.
2024 was a huge year for Starship, and 2025 is going to be even bigger. We've completed 6 test flights so far, and 4 of which were last year. And we're looking to dramatically increase the number of launches of Starship this year, with tons of exciting firsts coming, like in-space propellant transfer and our first attempt to catch the upper stage of Starship. Starship had some absolutely mind-blowing moments in 2024, most notably the first booster catch, which saw the Super Heavy booster return to the launch tower to be caught out of mid-air on the chopsticks, a major milestone to the path of full reusability. These flight tests are critical for iterating towards a fully operational vehicle, because the more we fly, the faster we learn. Development and manufacturing of Starship takes place at Starbase, one of the world's first commercial spaceports designed for orbital missions. Many new buildings and facilities, including the new launch tower and the 1 million square foot Star Factory designed with the goal of producing hundreds of ships a year, were built at Starbase in 2024. There's tons of work still to be done as Starbase continues to grow and transform into the gateway to Mars. And in addition to all of that, construction is underway at Cape Canaveral's Launch Complex 39A, where an additional Starship launch tower will be coming online. There's so much to look forward to in this era of space exploration, and we couldn't be more proud of our work with NASA to help humanity go beyond low Earth orbit again. But back to today's mission, let's learn more about today's secondary payload.
You, the public. So let's get a few of those questions into Ray. And Ray, are you ready?
Yep, let's do it. Let's answer some questions.
This question is a good one. Will we be able to see live photos or footage of the lunar surface from Blue Ghost?
So when Blue Ghost lands on the moon, we won't have live video or photo, but we do expect to get that first photo back within 30 minutes. So it won't be immediate, but it'll be relatively quickly.
You're also going to take some footage of a solar eclipse, right?
Yeah, so about 2 days before the end of the lunar day, we expect to see an eclipse on the surface. So we'll take photo and video of that.
I'm excited to see that. And you're going to have it in high definition. Surveyor, NASA's probes that went to the moon, caught that image, but it was nothing like the cameras that you have now. Also, I'm going to look for some levitating dust, like this glowing horizon. Talk about that.
Yeah, so at sunset, we expect the regolith on the lunar surface to do kind of what you said, levitate off the lunar surface and create this glow effect. And so we'll have our cameras, taking photos, imagery. A lot of the payloads on the lander are very interested in the regolith, so this will be an interesting event.
We'll get to see what Eugene Cernan saw in Apollo 17 during that last trip there back in 1972. Okay, next question. Famita asks, how long will it take to get to the moon?
So there are a couple different routes to take to the moon. The one that Blue Ghost Mission 1 will be taking is about 45 days. So we'll be spending about 25 days in Earth orbit, 4 days transferring to the moon, and then another 16 days in lunar orbit. And that's so we can get data, check out the payloads. There are some payload operations as well, so kind of an elongated trip to the moon.
Of all those days on that trip, what are you most focused on?
I think there's some critical events that are going to happen really quickly after launch. Priming that propulsion system is definitely first time. I think some of us will be holding our breath for a few hours there. So that's definitely the first key event to keep an eye out for.
And then autonomous landing is another one.
Absolutely. So when we go to land, just like you said, it's autonomous. So that's the first time our mission controllers will really be hands off. You can't even send a command at that time, and the lander software and cameras take over and pick the safest spot for us to land.
All right, Thirst434 asks, hey, Team Artemis, what will be the goals of this mission and how will it benefit humans going to Mars?
So this mission, we started talking about these payloads. There's 10 different payloads on board, all of them collecting different data. And so this will really inform all those future missions.
Exciting stuff. We are looking forward to it. And of course, as you mentioned, Firefly is interested in Mars as well. For the first time in more than 50 years, astronauts, including the first woman and person of color, will travel to the moon as part of NASA's Artemis program. Preparations for Artemis 2 are underway, and we have more on that in the Moon Minute.
Hi, I'm NASA astronaut Victor Glover, pilot of the Artemis 2 moon mission, and I'm here at the Vehicle Assembly Building at NASA's Kennedy Space Center in Florida, where behind me, booster stacking is beginning for the Artemis 2 rocket. Mission progress got a big boost recently when technicians with the Spaceport's Exploration Ground Systems team inside the VAB began stacking the first components of the Space Launch System rocket, the solid rocket boosters. 10 segments arrived by train to Kennedy in September of 2023, followed by extensive testing and inspections to prepare for stacking. Technicians inside the VAB are using the massive overhead cranes to stack the segments one by one onto the mobile launcher, which will be used to process, assemble, and launch the SLS rocket. Once all 10 segments are stacked on the mobile launcher, 5 on each side, the boosters will then help support the remaining rocket segments during final assembly, including the core stage and the Orion spacecraft that will take Reed, Christina, Jeremy, and me around the moon and back. The 177-foot-tall twin solid rocket boosters will provide 7 million pounds of thrust during liftoff of Artemis 2. That's a look at your Artemis Moon Minute.
Time now to tell you about another one of NASA's 10 lunar payloads on this mission. Next up is the the EDS, Electrodynamic Dust Shield, which uses an electric field to move harmful lunar dust off the surface in need of protection. And here to show us how this payload works is the principal investigator, Dr. Charles Buehler. Are you ready for some show and tell, folks? This one's going to be fun.
That's right, I got some props here to share.
All right, first of all, talk about EDS. What is it and why do we need it?
The EDS is a system developed here at KSC for the last 25 years or so.
Wow.
To lift and remove dust from surfaces without any moving parts, gases, or fluids. And we incorporated our EDS technology into various substrates to do just that.
And that's important because this regolith on the moon, it's abrasive, right?
It's very abrasive and it is potentially toxic, yes.
So we don't want that on our equipment or spacesuits or anything that's moving. Okay, so how does, you've got this setup here.
Sure.
And to your left, the thing that you're holding there, that's kind of what is encasing your payload, right?
This is actually the spare parts of our payload.
Okay, all right. So explain how that works when it gets on the moon.
So when we land on the moon, a few hours after landing, we deploy a fifth leg, or an SAA, Surface Access Arm, which will deploy 2 instruments, us and Planivac, and it will jettison us separately after that, a few hours later, and we will softly land on the moon like this.
And how are you going to make sure that you get regolith inside there? Because you need that dirt in there. You need it to get dirty.
We absolutely do. So we're trying to focus on 2 EDSs, self-cleaning surface, a glass and a thermal radiator. And what's going to happen is when we land, we have 6 other EDSs that their whole job is to lift dust from the surface and direct it and deflect it onto our EDSs.
Hold that up for a second, Dr. Buehler, because you can see through those little bands, right? What are those? It looks like that the dirt can pass through
them. Those are just electrodes. The
Yeah.
same thing in our transparent EDSs.
They can kick up the
They
regolith
sure
onto it?
can.
Okay. Okay, and so now let's show us how this technology works. Once you get it dirty,
Once
then
you get
what?
it dirty with the reduster, you can show here. So if you have a glass system, a camera lens, or something,
we got a camera
you can get
overhead.
it really dirty on the moon.
Oh, yeah? Okay.
And that's bad news.
Yeah.
So you don't want that. So you want to turn on your EDS, and then voila, dust will come
Look
off.
at that. just
All
right
you
off
need.
the surface.
Yeah.
And that is electrical current that's created.
That is an AC square wave signal.
Okay.
Low current.
Now, can we give it a tougher test? Can you really get this?
Oh,
I mean, we can get my 1.5-year-old to come in here and throw dirt. He's very good at throwing dirt. If you need help.
Well, we'll keep adding dust. Why not?
Yeah.
You know.
Hey, it's live TV. What could go wrong? Yeah.
Cover the whole thing. How about
Oh,
that?
now you're talking.
And what I can also do, once we de-energize that might take a few more minutes. It doesn't take too much longer.
So
We're
if
just
that's
talking about a
harmful regolith, literally nothing moving, no moving parts, no gases, and it's just coming off the surface.
pretty
And
cool.
it still continues to work it right off.
Yep.
That's fantastic.
And what's nice is if it's on, we can't get dust to stay on it. That's also very useful.
That's fantastic because these little dust particles, as I understand on the moon, as you were just talking, are like little shards of glass. So you don't want that stuff to stick. What do you expect to happen on the moon when you do this?
Now, on the moon, we have to polarize the dust, so that takes a little bit longer. So we apply a DC field for a few seconds, a few minutes, and that's based on the resistivity of the dust.
Okay, and Ray, it's been pretty fun to watch that, happen, and you had to make sure that this had good access to the regolith. How'd you do that?
Yeah, so as he mentioned, we designed this surface access arm, and so when we land on the lunar surface, that arm will deploy down, and then there's a hinge that we very specifically designed to get EDS to flatly land on the surface and get that dust up in it the way it needs to perform its science objectives. So.
And you can kick up a little more regolith if he needs it.
Yeah, well, there's other activities going on the lander that I think will really help get dust on there. You know, the Lister drill will be running. You know, there might even be some dust from landing, that impact kick up a little. So we'll try to get a lot of dust on your payload to help you out.
I appreciate that.
All right, very good.
Wanna be dirty.
I want one of these for my entire house. And just punch it and all the dust goes away. Then you really have something. We are looking forward to this experiment. Thank you, Dr. Charles Buehler, for being here. Thank you for the demonstration. And Ray, appreciate your insight on how you integrated into the payload. That's great.
All right, well, thank you very much.
All right, time now to tell you about another one of NASA's 10 lunar payloads. We're going to have so much more of these lunar payloads coming up in the show. We're going to get to that in just a little bit. You may have heard us mention CLPS, which is the Commercial Lunar Payload Services Program at the beginning of the show. Let's dive a little deeper now into this relatively new NASA initiative.
Our moon. It seems so close in the night sky, but getting there is really hard. But what if there was a way to change that? Only a few nations have successfully landed on the moon. As NASA sends astronauts back to the lunar surface, this time to stay, we will need to send science and technology instruments ahead of time to lay the foundation for human exploration. To make this happen, NASA is helping establish a commercial lunar economy. For the first time ever, there will be commercial delivery to the moon. We are enabling American companies to send our payloads to the lunar surface for us. These delivery services will expand our capabilities for exploration, radically increasing the amount of science we can achieve. This high-risk, high-reward initiative will invest in and leverage the entrepreneurial spirit of American innovation to launch a commercial lunar marketplace, advancing technology and exploration for all of us. With this never-before-seen streamlined access to the moon, we will be able to make novel measurements and develop technologies that scientists have long wanted to do on the lunar surface. And as this new industry matures, this commercial delivery service for NASA and other customers could expand beyond the moon to other destinations in our solar system. And we can learn to live on another world because we are explorers.
And we're getting close to liftoff, just T-minus 8 minutes and 15 seconds until launch of Firefly's Blue Ghost lander on a SpaceX rocket.
Surface, that arm will deploy down, and then there's a hinge that we very specifically designed to get EDS to flatly land on the surface and get that dust up in it the way it needs to perform its science objectives. So.
And you can kick up a little more regolith if he needs it.
Yeah, well, there's other activities going on the lander that I think will really help get dust on there. You know, the Lister drill will be running. there might even be some dust from landing, that impact kick up a little. So we'll try to get a lot of dust on your payload to help you out.
I appreciate that.
All right, very
We
good.
wanna be dirty.
I want one of these for my entire house. And just punch it and all the dust goes away. Then you really have something. We are looking forward to this experiment. Thank you, Dr. Charles Buehler, for being here. Thank you for the demonstration. And Ray, appreciate your insight on how you integrate it into the payload. That's great.
All right, well, thank you very much.
All right, time now to tell you about another one of NASA's 10 lunar payloads. We're going to have so much more of these lunar payloads coming up in the show. We're going to get to that in just a little bit. You may have heard us mention CLPS, which is the Commercial Lunar Payload Services Program, at the beginning of the show. Let's dive a little deeper now into this relatively new NASA initiative.
Our moon. It seems so close in the night sky, but getting there is really hard. But what if there was a way to change that? Only a few nations have successfully landed on the moon. As NASA sends astronauts back to the lunar surface, this time to stay, we will need to send science and technology instruments ahead of time to lay the foundation for human exploration. To make this happen, NASA is helping establish a commercial lunar economy. For the first time ever, there will be commercial delivery to the moon. We are enabling American companies to send our payloads to the lunar surface for us. These delivery services will expand our capabilities for exploration, radically increasing the amount of science we can achieve. This high-risk, high-reward initiative will invest in and leverage the entrepreneurial spirit of American innovation to launch a commercial lunar marketplace, advancing technology and exploration for all of us. With this never-before-seen streamlined access to the moon, we will be able to make novel measurements and develop technologies that scientists have long wanted to do on the lunar surface. And as this new industry matures, this commercial delivery service for NASA and other customers could expand beyond the moon to other destinations in our solar system. And we can learn to live on another world because we are explorers.
And we're getting close to liftoff, just T-minus 8 minutes and 15 seconds until launch of Firefly's Blue Ghost lander on a SpaceX rocket. Ray, the journey to this moment began for